Earth data is collected on a daily basis to manage projects, resources, and to better understand how the Earth is changing. Data collected from the ground, space, and across time can reveal new insights. We see the integration of multi-sector Big Earth data to gain new insights as one of today's biggest challenges. What if we could bring technologies together and put it into the hands of decision makers, providing the ability to look back in time and into the future? We could make a difference and ensure we leave the Earth a better place. It's time to change how we manage our planet for future generations. Catalyst. Earth data simplified.
Good morning, good afternoon, and good evening to those of you joining today's webinar, Breaking the Cycle with Condition-Based Vegetation Management, and thank you for attending. My name is Dan Purcell on the sales side, joined by Andrew Sitt, Product Development Manager, and we're excited to kick things off today. Today's agenda will cover the following topics. First, we'll introduce Catalyst and the 40-year heritage of technological innovation, why we need to target resources, the benefits of condition-based prioritization, and following, Andrew will take us through Catalyst Insight's vegetation management solution and provide us with a demonstration. Catalyst, a PCI geomatics company, has been innovating Earth observation software for over 4 decades, serving creators and users of Earth observation data. This heritage, working with satellite and aerial imagery providers, space agencies, government, and academia, touches much of the data and imagery we see and use today across many sectors. Catalyst solutions fall into 2 broad types. On the left, we have highly scalable workflows and solutions for remote sensing and photogrammetry experts that are creating imagery, data products, and analyses. On the right, we have Insights, an automated environmental risk monitoring data service for decision makers who simply want timely, actionable insights in which we leverage our scalable workflows. We use a robust scientific approach which is highly scalable through tried and tested algorithms across multiple use cases and industries. Catalyst is sensor agnostic, which allows our team to pick the best tool for the job. We obtain the best image stack, having used data from many sources. Having many image supply options allows our team to pick the best tool for the job. We obtain the best image stack for that matter. Whether you want your solutions fit for cloud, server, or desktop, we can support whatever is appropriate for you. Lastly, why not utilize previously collected imagery to generate added value and extend the shelf life of what was already collected? In North America, in particular, utilities are spending billions of dollars annually on inspecting and clearing vegetation from their overhead lines. Fines for non-compliance are up to about $1 million per violation, and in particular, California, wildfires caused by vegetation encroachment have led to civil claims in excess of $25 billion. In a recent survey, most utilities indicated that their vegetation management budget was insufficient to properly mitigate risk using their current processes. The big question is, are current budgets sufficient to inspect your network frequently enough to mitigate those risks? Most utilities can't keep up with the problem and can't afford to keep throwing money at it. Now, this is definitely not a case of any publicity is good publicity. You don't want to be in the news with these headlines. Increasing weather events such as wildfires, hurricanes, snowfall, and ice buildup are testing the grid's resiliency more than ever. With the unpredictability and scale of such events, is there a better way we can reduce the frequency and duration of these outages? Now, I'd like to showcase the differences between the 2 processes of condition versus cadence-based and how they cooperate together for an improved vegetation management program. Most utilities are still doing their vegetation inspections using a cadence-based approach. If you're operating on a 3 to 5 year cycle of ground-based inspections, tree growth and deteriorating health are likely to outpace that cycle time, creating new risks every single year. Our solution offers a condition-based approach to planning your vegetation maintenance operations, highlighting the highest risk areas so you can break that cycle and improve the efficiency of your overall vegetation management program by up to 30%, and at up to 20% less cost when compared to an approach that only relies on cyclical visual inspections. Now that we have the ability to identify and highlight high and low risk areas, why spend valuable time and resources inspecting areas that you know are at low risk at the same time and frequency as the areas that are at high risk? Our solution empowers you to make a data-driven justification for why those low-risk areas can be inspected much less frequently. When it comes to costs, satellite imagery is already the least expensive inspection methodology for this application, and costs continue to decline as more satellites go into orbit. Now, we aren't trying to say that you don't need ground-based inspections at all. These are still things there are still things you can see from the ground that satellites cannot. We're saying that satellite imagery plays a key role in the technology mix and for a modern vegetation management solution. Satellite imagery enables a tip and cue approach so that you can deploy the ground crews much more effectively and efficiently. And what I mean by tip and cue is using satellite for large-scale analysis, pointing to hotspots of high risk to target ground crews. With satellite inspections costing 1/3 of ground-based inspections on a per kilometer basis, they can be phased into existing programs without disrupting existing operations and processes and without a large increase to your budget, but still having a very significant impact on the outcome. With the same budget, you could get a high-level inspection of the entire network from a satellite imaging solution and deploy your crews to only inspect the areas that actually need attention that year. The same dollars will have a higher impact on the results that matter, reducing the duration of outages, reducing the frequency of outages, and mitigating the risks of catastrophic failures like flashovers and wildfires. Utilities that are set on cycles, this approach helps avoid cycle buster events and may allow for more work to be completed within a cycle, and in some cases shorten a cycle. Now, I'd like to pass this over to Andrew so he could give us a demonstration of what the Insights Vegetation Management solution offers. Over to you, Andrew.
Thanks very much, Dan, and thanks again to everyone who joined us today. Now, before I actually jump into the demonstration itself, I just wanted to spend a little bit of time explaining how the system works for those that may not be familiar with satellite imagery or how to use it for vegetation management. So really, our processing starts on the left-hand side where we task a satellite to go capture images of the area of interest from multiple vantage points. So they call that stereoscopic imagery. This usually only takes a few days to get the images. And I want to highlight here that there's no capital investment here in acquiring the inspection data at all. No logistical challenges with deploying a survey crew, whether that be aerial or ground-based. We really just ask the satellite provider for the data. It takes a couple days for the satellite to get there and take those images, and then we're off to the races. So from those images, we use that bank of industry-leading algorithms that Dan was describing on the first few slides there to generate a 3D model of the area. We're also getting infrared data through those images, and that lets us assess the vegetation health. And then we combine that 3D data with the vegetation health to come up with a probabilistic risk model for all the vegetation that's nearby to those utility assets. So we're calculating a grow-in risk and a fall-in risk independently. And then we are doing further analysis to prioritize which threats you want to address first. And then, On the output side, we're able to output to any of the standard Exchange GIS file formats. We're also able to work with your team to integrate into a work management system or an ERP, or you can just stay within our web platform, which is what I'll show today, and drive your crew's work orders that way. So the data we're going to be looking at today is from the province of PEI. We chose this area because in September of 2022, they had a big hurricane blow through the area and essentially knocked out power for the entire island of PEI. So there were at least 80,000 customers without power, some of them for up to 3 weeks, 40,000 down trees and branches, and ultimately it was a $37 million hit to the utility's bottom line. What makes this example sting a little bit more is that earlier that year, they said that the utility said that roughly 75% of their overhead lines in their network needed urgent attention from a vegetation management perspective. So again, it just highlights Dan's point earlier that utilities know this is a problem. They know it's an expensive problem, and they just can't keep up with the budgets and the methodology that they're using today to properly mitigate those risks. So with that, I'll jump over to the demonstration itself in our web platform. So here you can see our study area. This is province of PEI, obviously, and we picked about an 80 square kilometer area within that within the island to do this case study. We commissioned that high resolution imagery, and you can see the power lines here have been digitized for the whole distribution network within the area. Now, PEI is a relatively small province and relatively sparsely populated province. And even with that, to inspect these lines using their traditional methodology would take them years for the entire island. So, the ability to get this high-level inspection in a matter of days is really a game changer. Just to highlight, this is a visualization of the 3D model that we're able to produce. So you can see very high resolution, and you can see the proximity to the lines here. So this is what we're using as an input to the geometry side of our risk modeling. So, as I said, from that 3D model and combined with the infrared data that we're getting with the satellite imagery, we're extracting all the vegetation in the area. So that's represented by these green polygons. And then we're further sort of categorizing that vegetation into to highlight those risk areas. So with each tree, we are calculating both a grow-in risk and a fall-in risk. And we're doing that independently because obviously those are different types of risks. And then we're also combining those two probabilities into a threat index, which is really just the probability of a grow-in or a fall-in happening from that particular tree. Sort of the next step in our processing is we are associating those vegetation threats with the spans that they're actually threatening. So you can see here down in the table for each span, we've got the number of threats to that particular span. We've got the maximum threat from any of the trees that are threatening that particular span. And then we've got the overall threat. So again, that's a probability of any of those trees having a either grow-in event or a fall-in event. Lastly, on this page is to highlight this threat density column. So this is sort of that additional layer of analysis that we're doing. And in this case, we're looking at not only the vegetation that's threatening a single span, but all the threats in the area of that span. And the idea there is that we're able to prioritize by this and enable your ground crews to be more efficient, because most arborists can prune more than one tree in one day. So being able to deploy them to an area where they can set up, unload their equipment, and keep their chainsaws running all day rather than transiting from sort of tree or site to site, allows them to be much more efficient. I'll pause here just to say also that when the utility can provide additional data about number of customers served on a particular span, or the impact of an outage from that particular circuit, we can also use that to provide additional prioritization metrics. This next view is just showing a land use map that was available from the province of PEI. So again, the other thing that Catalyst has a very strong pedigree in is working with all kinds of map data to come up with these analyses. So in this case, the land use is important because you can see we've got agricultural land and forest land and residential areas here, and this enables us to classify the land underneath the utility assets as private versus public, for example, and that can alert you to the fact that you may need to request permission to access a particular site if it's passing over private land. We can also incorporate all kinds of other map data as it, if it's available, whether that be soil type or soil moisture, which can impact our risk modeling, or various other examples. So just before I hand it back over to Dan, I wanted to go through a little example of sort of how we see the workflow working here. So here I've got both the trees and the spans highlighted and colored there on the map, and I'll actually start with the spans here, and I'll say as I said, we think that threat density metric is a really good prioritization method to keep your crews efficient. So I'm going to say, where are my top 10 highest threat density areas here? So you can see there it's a little bit tricky at that zoom level, but those areas got highlighted in blue. I can jump down to any particular span and take a closer look just by clicking in the table there. And you can see here this span obviously has, about a dozen trees that are threatening it. And then it also has, a bunch of threats to, in the nearby area. So, the crew could set up here and trim all of this, hopefully within a day, or at least sort of all in one go. Similarly, maybe you do want to sort of just tackle your very highest risk fall-in threats. So again, instead of looking at the spans, we can look at the trees, and we can sort the table by fall-in risk. And again, I'll highlight, those top 10 fall-in risks, and they'll get highlighted there in the map because it's all interactive, and I can jump down again and do a little bit of a closer inspection. We can hover to get a tooltip to see some of the data that's driving these insights. So just before I hand it back over to Dan, just wanted to sort of summarize and saying, we're getting this data really fast. From the request to getting these insights can happen in a matter of days. And, we're leveraging that expertise in photogrammetry or image processing to come up with that really accurate 3D model that helps drive all this analysis. So with that, Dan will help us wrap it up here.
Thank you, Andrew, and great demonstration. Now, to conclude, Catalyst Insight's vegetation management solution enables utilities to inspect the entire network in days at scale without having to adopt new enterprise operations tools. It enables you to focus your ground crews on the highest risk areas to reduce unplanned vegetation-related outages. Now, I'd like to end on this quote Data-driven visual intelligence can significantly reduce vegetation management costs by up to 20% and tree-caused unplanned outages by up to 30%. The key messages here is utilities are able to could spend less or restructure costs to get a better outcome. So I'd like to thank you all for joining today with Andrew and I to run through this presentation and webinar. We would like to extend an invite out to you to connect with either one of us so we can help you discover your network's top risks. Thank you very much for joining.
Thanks very much, everyone.